what a lovely day!
Welcome to Flat Earth Debate Live. I'm your host, Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they are live. There's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and Twitter. And one last time, if you're new to the channel or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to keep up to date with the Flat Earth Debate. Now we are joined by Paul Hall, Sleeping Warrior, the Adam Meakin, who else we got? Brian's Logic, and I believe 10th Man. Is 10th Man there? He's normally got a square that you can't see. Also a whole bunch of people in Discord, so welcome one and all.
Hey. 10th Man said he couldn't make it today.
Okay, fair enough. I'm going to do a quick shout out to my latest channel member, which is Kevin Tooth. He's my latest penguin. Thank you very much for joining as a Nathan Oakley 1980 channel member, Kevin Tooth. Any signs of a physical geometric sphere edge horizon, formerly known as Earth curve?
No.
Nathan, I thought you were a bit of a scaredy cat yesterday. I thought Rumpus was very much on point. He had you in the corner, Nathan. He had your toes to the fire. You should have let him speak more.
Yeah, if you say so, Anthony.
To be honest, it was a brilliant example of how they can't. I don't. Do you know? It'd be interesting to see how many ballers pick Rumpus as his. Like we've all been picking our best two people with yourself as a substitute. Wonder how many people pick Rumpus.
Rumpus is underappreciated. I can't believe I'm being forced to do this because I was explained that there was a straw poll. Rumpus didn't appear on it, and neither did Zanuck, and there was a few others that I'm not going to mention. But nevertheless, they were pointing out that because they use doublespeak, because they contradict themselves, that's why they wouldn't have them. It's like, don't you realise that you're on the losing side of this argument, and that if you're on the losing side of the argument, that is essentially an essential tool in your toolbox? Because what are you going to do? Lose and concede? No. You need to keep going indefinitely. Never actually show that you've actually reached the point where you've lost. That's why we end up with scaredy cat, and testing 1, 2, 1, 2, rather than addressing the fact that you can't measure a geometric horizon. That would be a tangent point. If you've got an apparent horizon that isn't geometric by their own definition, that's never going to have a rebuttal. It's a contradiction. So, scaredy cat, and testing, you're never going to respond. I only get 2 seconds. That's what we get. Hey, Arwin.
Hello.
Any signs of axial rotation of the Earth-based variety?
One.
No.
Grab it.
Go, Chemo, go. Go, Chemo.
Hold on. Michael.
You're a valued member of the team.
Hello. Can you hear me now?
Hello. Good to have
Afternoon,
you.
Spurs.
Hi. Hold on.
Hello.
Yeah.
It's about
Did you get to the gravity part or anything like that?
Any scientific evidence of gravity?
No. They've conceded. They've given up. They've decided because now what they're doing. Because we went through it last night, and after this show, I'm going to upload the discussion on it. But they're now trying to figure out a new solution for this effect that they see happening. So Mr. Scott, Kosho, Jem, all of them, they all recognise gravity is no longer a force. They know you can describe it as a force, but they don't consider it as a force as mass attracting mass anymore. Like I said,
So what do they think it is now?
Can somebody drag fight the flat Earth into the 21st century?
like-
Because he still thinks it is.
Spurs.
Nah.
Are you done, Spurs? Is that all you had? Is there anything else you wanted to add?
No, basically, that's essentially is that they've given up the ghost of gravity. It's hilarious to listen to them talk to an alternative now of what it is. What is this? What is it? What is this? What is gravity? Or what is it? If it's not a force, what is it? They're trying to figure out what is gravity. Yeah.
That's why I've always said that they can't even define it, because whatever you think it may or may not be, right? It's currently defined in current physics, right? Einstein did it. Not only did he define gravity, he told us what causes it. Now, I don't necessarily agree or disagree. I don't really have an opinion. But if you're a baller, you better be telling us that the effect of the curvature of space-time is caused by the uneven distribution of mass, and then tell us how Newton's apple falls from the tree. Good luck with that one.
Well, for Einstein to even be valid, everything has to be in motion. If things are at rest, Einstein falls apart. But even the idea of gravity falls apart, or a force falls apart, because you got to have acceleration. So if things are at rest, how is there a force in play?
Okay, let's just summarize what the situation actually is. So what we're saying is in 2020, people have now appreciated and understood that your Newtonian force has been superseded by newer bullshit pseudoscience called Einsteinian gravity, which is not a force. So it's taken 105 years for these idiots to catch up with not the latest bullshit. Now, bearing in mind, we've taken 3 years to get these fundies to the point where they parrot the correct pseudoscience for their religion, which is Einsteinian gravity. That's the heliocentric force that's not a force. You can think of it as a force. That's what they should be parroting. Einsteinian bending of pseudo-Ramonian force space. That's their force. That's not a force, but you can think of it as a force. Anyway, it's not the current science. Hold on. It's not the current science, though. Oh, it's already started, the rumpusing. So once they're parroting the correct pseudoscience of Einsteinian gravity, we can start pummeling their pseudoscience that they should be parroting. It's just taken 105 years for them to start parroting the incorrect, now debunked by quantum mechanics, pseudoscience that is Einsteinian gravity. Well, hooray! Maybe just another 105 years before they get to understanding that quantum mechanics has pummeled that pseudo-nonsense into the oblivion that it came from.
So another point I want to try to bring up. So speaking with Gem Panda, and so they were like, well, where's the model? Where's the model? Where's the evidence? Where's the evidence? So I was essentially saying, well, the black swan is the beginning of the end of the heliocentric model. And I said to him, even if I was able to give you a model, a fully working model right now, today, here and now, and gave it to you, presented it to you, I said, how long do you think it would take for the entire world to catch on to this model, or accept this model that I've just given to you, that you've now accepted as a working model? We would still have to wait before everyone accepts it. So I said, this is a similar thing with the black swan argument. I've presented something to you that just takes time for the turnover. So it's not like we can just, convince everyone of flat Earth overnight. But this is the beginning of the end of the heliocentric model. So the idea is that they want a model, wouldn't it? I said, what would a model do for you anyway, right? So yeah.
Can I just point out that if they now accept that gravity is not a force, the next thing that we ram down their necks is, well, what's buoyancy then? Because that needs gravity to be a force. And if gravity is not a force, then buoyancy, both mathematically and physically, cannot exist. So why do helium balloons go up then?
Go on, Owen.
It's just relative density. It's what it always is.
I know.
And relative density, it has this slight problem, mainly that it doesn't play into the idea that gas could be kept in some way sticking to a ball, opposing a giant outer space vacuum. And that's really the only problem they have. Because if they didn't need to assert that, then relative density is going to work fine. Everything's going to work fine.
I was quite excited to hear Mr. Scott go, because he's got a PhD in maths and all these kind of things. So it was quite excited to hear him say, "Oh, it's not a force. We know it's not a force." But we're trying to figure out, and just today, Kosho and the guys there were trying to figure out, well, what is gravity then? What is going on if it's not mass attraction?
Is only relevant. There's no such thing as buoyancy. There was no mass. There was no such thing as mass. There's no such thing as gravity, and there was no such thing as buoyancy. Buoyancy is just floating, and floating is only relevant. What they call buoyancy is only relevant to liquid, and it's just volume, area, design, and displacement. That explains buoyancy. That explains why things move.
So hang on, I've just realised we can reform one of the questions with regards to gas pressure. If they now accept that gravity is not a force, instead of saying how do you have gas pressure without a container, what we can say is, why does all the gas pressure pool at the surface and disperse up? Because if the minute you say it's pooling at the surface on the Earth, then that implies implicitly that we're a container, right?
No,
it's
not pooling.
Where's gravity now then?
Stop. Humorous though it may be, a gas is not pooling. So in the pre-show, a guy's like, why is there less gas at the top of Everest then? It's like, well, there's less gas because the gas has made its way up by way of entropy to the top of the mountain, even though there's very little vegetation up there, if any. Well, that's an entropy increase. It's been produced at ground level and gone up. Well, that's not pooling.
No, you're right. You're quite right. I'm conflating the term, and I probably shouldn't do. I'm assuming that everybody understands that the biogeochemical cycle is the reason why the gas density gradient exists, because all the gases are created at sea or ground level. We learned it when we were 10. We've forgotten it, but now we're remembering it because it's important. But on their model, if gravity is not a force, then it must be pooling on their model because they haven't got anything pulling it down. So it must be pooling on their model, right?
I don't care. Their model and what it does or doesn't do.
What they never deal with is the fact that different gases are up higher than other gases. Some gases are up higher than other gases. Some gases are lower than other gases. That's all part of relative density equilibrium. So it'd be interesting for them to actually come up with what is the actual mixture of gases at the top of Everest. Which gases are most prevalent there?
I think that's been well established.
Yeah, but they don't. They just say it's the air is thinner up there. It is. Air is thinner up there. But air is a mixture of nitrogen, oxygen, mainly nitrogen, and then oxygen, and then you have 1% trace gases. But like if they're talking about air or oxygen, which is only a part of what we breathe, there's less of that there. But there's other gases up there that there's less of down here.
I think that especially the levels of nitrogen are low.
Have hydrogen and helium up that way, rising up, then you will have air, oxygen. You know what I mean? It's like it's always how come there's less gas at the top of Everest? No, there is less gas, but there's also it's the mixture of gases that are up there. It's going to be different from down here.
Owen?
They never do that.
Hold on, Brian. Go on, Owen.
No, yeah, correct. And at the top of Mount Everest, I think what a distinct difference is that the levels of nitrogen are much less. And that matters a lot for how the gas actually behaves as it's being absorbed in your blood and all that. And why people need a pressure mask. It's not even about the oxygen. It's about just the total mixture of gases being so different that it's hard for your body to assimilate and all that.
Okay, but the bottom line, this is great. I know it's a discussion about gravity, which is not a force and doesn't do anything to gas. However, entropy, which describes how the gas, which is produced at ground level, fills the available volume, would dictate that if the available volume to it was a sky vacuum, it would fill that sky vacuum and we wouldn't have any gas here to breathe. Ergo, the sky is not a vacuum. Unless there is any demonstration that you can have gas pressure without the necessary antecedent of a container. Is there?
No.
That's interesting what Armin said as well, because nitrogen is less dense than oxygen, so it actually sits above oxygen. They just the wind and the weather mixes them. This is what they say. So if there's a nitrogen problem up there. There's definitely an oxygen problem up there. You know?
I don't know. I think because it is so high up that also levels of helium and hydrogen are higher. So it becomes more of a filler instead of nitrogen, which is a filler gas. You don't actually absorb that.
Yeah.
And I think that because of the density difference of helium and hydrogen, it's not good for you. Hey, if you just breathe hydrogen, that's not good for you.
No.
That's right. So if just the relatively harmless nitrogen, if that lessens and then is filled up with these, less dense gases, that can definitely have an influence. But you might be right that just the levels of oxygen are also lower.
They're, as you go up, the concentrations hardly change. It's the amount that qualifies. So I think at Everest, you've got about half the amount of air pressure or less, but the actual ratios of oxygen and nitrogen are still the same.
That crap's all over that, Brian.
Yeah, well, yes and no, because there's still different gases up there that there's more of than we have down here. Because
there should be.
We don't have that amount. Like,
hold on a second, Brian. Hold on, just 1 second. Do you want to qualify what you've just stated, Adam? Just because otherwise we're going to go around in circle. Brian's just asserting the exact same thing again.
I'll read it from the Everest and indeed other 800 using oxygen. So as you go to even moderate altitudes, the air gets thinner, i.e. there's less air pressure. At around 5,500 meters, there is half the amount of air that you would find at sea level. Despite there being less air, it is still made up of around 21% oxygen, 75% nitrogen, and 3% and rising carbon dioxide. There is small changes, but it's negligible to,
All right.
Hold on. You're saying, hold on, there is a difference, though.
There is, I think it's saying here, as you start to, and 3% and rising carbon dioxide plus a small fraction of other gases. So I'm not sure what the and rising indicates, but I mean the general. I'm
just trying to figure out if that document's downplaying it. Negligible change is still, there's a difference, right? If there's a difference, Brian could be right. If there's not a difference and it is exactly the same, then it's just the pressure that's going down. But it depends how they're spinning it.
Would be right, but it's dynamic, so it's never going to have the chance to be. At those lower levels, there's a lot more dynamic effects, isn't there? So it's only when you get a lot higher that things tend to settle into layers. It's a lot more mixy lower down. Just that whole area is mixing a lot more, subject to all the winds. I think a lot more in it. But there's still I think as Brian's suggesting, a tendency to separate, but not. It's not able to because it's dynamically mixing with winds and the thermal effects of the sun, etc. So all the time. So.
Well, if I may add something to that, it kind of reminds me about what I learned about metallurgy. And that is what happens when there's a lot of trace metals instead of the main type of metal in there, how that affects even the melting temperature and how fluid it gets and all that and strength. And yeah, at the bottom on the Earth, there is a lot more trace gases, which means there's just more different types of gases in there having their influences, trying to, affect things, or it just affects things. And up there, it's less. So it will separate more easy. It does make sense to me on an intuitive level, at least.
Yeah, I'm not going against any of it. What Adam said was totally fine, and I totally agree with it. What I was saying was along the same lines, but my point is that there's gases there. I reckon in more like helium and hydrogen there has to be more of that up high than there is down low, because it doesn't stay down low.
Okay, and that's the problem though, isn't it? So up high, what's up high?
Well, it's up high. What's up high?
Yeah, If I say you, for example, I'll qualify it. If I say you're going too fast, if I tell you you're going too fast, and you go, well, how fast was I going? And I go, too fast. You're not going to get anywhere. No one's going to understand what we mean. So if you say you go up high, what's high? Now, on screen, I've got a heliocentric depiction of what could be considered quite low, right? In their terms. So what's quite high? Now, I'll just add one more thing, Brian, I will let you go. So given that we don't know the parameters of our containment, what's quite high?
Yeah, okay, I understand what you mean now. Well, I was talking about more just
No, but that should be easy to answer, though, because it all relates to the amount of space available. So, yeah, if you're going to say up high, then does that mean the top half of the available space?
I'm going to get to sit with almost a globe head here.
Saying it's not, you can't, you can try and quantify it, but you can't. So just, you have to accept that you don't know whether that's near the top, nowhere near the top, or whatever.
Top, you say?
Right, but
hold on, Owen. Hold on, Owen. What's this word? Top. What top? What are you talking about, Adam? The top? What top?
Yeah, fair point. That's why I laughed. We have no way of determining any scale to it, whether there is a top, what containment, where the containment begins. It's what you can say is what it is at the altitudes that have been measured. Is all I would say. There is a tail off, Byron.
Yeah, we can say what we see. Okay, wonderful. But I'm appealing to the flat earthers now, not the globe heads, right? None of you have got the slightest idea what the sky is. So just get that through your thick heads, all of you. None of you know what the sky is. Stop telling people what it is. And the same goes for models, right? Keep shouting them out, and I'm pretty sure it'll just get deleted from YouTube eventually. But there we go. Thrice-8 Hermes, check him out. When he talks about models, he's in a slightly different context, but the point is the same. When he's talking about following another man's model, it might be a political model that he's talking about. But models are still models. Yep. So when, I think it was Spurs earlier saying, well, he's being demanded of a model. Well, why should Spurs or me or anybody else be the arbiter of another man's way of thinking and perceiving the world? That's all a model is. My model, the place you want to get to is where you've got your own model and you understand that your model isn't a representation of reality. It's your construction that lets you perceive the world, as opposed to someone else's model, for instance, a globe, which has been, in this example, foisted upon you without you even realising it. But these are just models. We don't know what the sky is, and we don't know what the world is. So don't make up a model.
No, but we do know that gases that of less density rise above gases of more density.
Yeah, let me just give you that bit and I'll show about it. So this bit I've got, look, up around 100 kilometres, the composition is fairly normal in that what we surface dwellers would expect, as stated that previous composition. After 100 kilometres, the percentage of molecular nitrogen and molecular oxygen decreases sharply, and there's also a similar sharp increase in monoatomic and triatomic oxygen, better known as ozone. Also, a small increase in the percentage of monoatomic nitrogen and nitrogen compounds, and argon disappears entirely. So you do start to see then higher up the effects of the heavier gases not continuing.
Thank you for bringing clarity to that, Adam. Now, bearing in mind that I've just said the same thing in the pre-show to a different dude, you weren't here, but I'm going to say the same thing to you. Who cares? What the hell does this prove? Who cares?
I'd like to say something. Even let's say the gas does layer up like that. If the top layer disappears, what happens to the second layer? What happens to the second layer after it disappears? What happens to each layer as it disappears into the void? What happens to the layers below that?
Well, that's the only thing you can say that you can assume is that because we still have pressure, there is containment. To say, well, what happens if the top layer disappears, to me is the thing that you can say isn't happening. The top layer can't be disappearing.
Perfect.
Otherwise,
perfect. You two are ace. I could kiss you both. So Paul phrased it as a question and Adam answered it. Right, that's the point. It's our point. But when we're discussing the gradients and the dispersion of the gases, the separation, the density, all of this stuff is irrelevant. Completely irrelevant. It doesn't prove anything about anything. The only reason, generally, we're discussing that subject is because we've been asked why there's a gas pressure gradient. And the reason we've been asked is because the person who's asking us has been asked how we can have gas pressure, or a gas pressure gradient for that matter, without containment. So we end up with us pointing out how entropy works and why you end up with gas at the top of Everest at all, i.e. there's been an entropy increase. Well, when you're describing that, unless you actually reach the point that you go, well, this is only relevant to us, because all we're doing is detailing how entropy works. Well, when you're detailing how something is, what's the point? Well, no, it doesn't prove anything, until you point out that the sky is not a vacuum. But for the guy earlier who was doing the same thing, he's asking us about how gas pressure works, how the gradient works. Well, why? Originally, Quantum Racer, when he originally postulated the argument amongst this debate, he was saying, why do I need to explain to you how a gas pressure gradient works? Where'd you get the gas pressure from in the first instance? I'm not going to tell you. Because why should I be charged with explaining why we have a gas pressure gradient? It's not relevant to anything I'm claiming. Now, if they're claiming it proves a point, well, what does it prove? Well, it proves that it dissipates to zero. No, it doesn't. That's a violation of natural law. So other than us pummeling your claim, there's no necessity for us to discuss this. It's interesting, and I thank you. I just want to add that at the end. So Paul, Adam, thank you very much. Same goes for you, Brian. I'm not knocking you. It's a fascinating subject to discuss, but I just don't want people in the audience to feel like somehow we have to justify what the sky is or how the gas works or any of this nonsense unless you're making a claim about it. So while it's very interesting, I just want to get to the point where it's like, what does this prove? Same as the guy who was on the Globe side that did it in the pre-show.
Yeah, I understand.
On that note, though, if there's anything any of you do want to add on this before I add scientific hypothesis and the lack thereof to the housekeeping questions we haven't asked yet, anything anyone wants to add?
Well, I think it's summarised it nicely. It's a point of wonder, something that, like I say, is totally irrelevant to how do we have gas pressure without containment. But when we then accept that, that's something that, like I say, at the moment, is a point of wonder.
I just wanted to add that I am definitely going to assert a lot of things of what the sky is. But all of those things are going to contain a limitation to the amount of space available. So, yeah.
It's necessary to speculate, to wonder, to dwell on points of folly, because they may turn out to be extremely useful. And from a fascination point of view alone, I'd love to know what the sky is. I really, really would.
Right. Yeah, so hey, I'm fascinated by this perceived concept of this potential barrier that seems to not be a physical edge, but rather like a energy barrier or something in between the air, because there seems to be just more air beyond. It's not like you're approaching a mirror and suddenly like you could, oh God, this is the edge. It was all a reflection. No, that's not happening. Just things that seem to be bumped in. So what is beyond that? Is that energy field or whatever surrounding us, containing us? If it's not the end, does that mean that we're like in a super giant cave or something that's even bigger and higher up? You know, these types of things are the concepts that I kind of dwell upon. Like, what can it turn out to really be? There just seems to be more space beyond the barrier.
And for more speculation, tune into Arwin for the early bird, which goes out an hour before the debate, 1 p.m. UK time, 2 p.m. Amsterdam time. That's on ARWIJN, Flat Earth Early Bird. Be here or be sphere.
So, I mean, what's interesting about this Einsteinian Newtonian is that with Einsteinian, if the Earth is a ball, then it must do what Einstein suggests. Which is bend the space, the fabric of time. That's if the Earth is a ball of this huge mass of what they describe. So is Anthony still there? So what is the next step then? Now that we've got them on no force, We understand it's the Einsteinian force. Well, where do we direct them
Einstein
now?
wasn't a force, so it's an effect. And where do we go next? Explain gas pressure. Explain all the things that you tell us that are dependent on gravity.
Because look, if we say, okay, if they say, yeah, it's Einstein, and we say, okay, yeah, it's Einstein, well, then it's like, well, are we presupposing now there's a huge ball bending space-time?
No.
No. They can explain how my egg moved if it wasn't gravity pulling the water down and pushing the egg up.
Go ahead, Sleeping Warrior.
They can explain how my egg moved because they say the gravity pulled the water around the egg down, and that created a buoyant force that pushed the egg up. Well, if gravity's not a force, it can't pull anything down, can it? But I did manipulate something when I poured that mass in, right? So how do you explain that without gravity? Because that's the basics, isn't it? Things appear to fall, some things appear to rise. Well, we need to explain things without gravity.
Did you hear what I said? Where does Einstein fit into your experiment?
He doesn't.
Einstein's space-time is conceptual, mathematic.
Right. He's conjuring his own new, his own new medium. So
Can I ask Spurs a question? Are you struggling to see the usefulness of this tool now? Is that what you're trying to get at?
No, I know that. I'm just saying that we should now look at the idea that they've, obviously if it's a presupposed idea that this bending of space-time is a thing, what if the globe earthers say, yeah, okay, we know it's not Newtonian, it's Einsteinian. Einstein was right.
What?
Right,
what are you babbling about?
The problem they have, the main problem they have there is the fact that the speed of light is based on a pre-assumption. That's where the speed of light comes from. It's based on a pre-assumption. And the thing about this constant speed of light thing is a load of rubbish because the pre-assumption is based off of is Kepler's analemma. And in that analemma, that they're basing it off the speed we supposedly go around the sun. But that is a constantly changing speed. A lot of the ballers don't even notice. It's a constantly changing speed that we're supposed to be going around the sun, or the sun goes around us. It's supposed to be. It's constantly changing. It appears to be changing throughout the seasons. So there is no constant speed of light.
Sorry, just do a quick shout out to that flat fellow who sends me a cool emoji. Thank you very much indeed for the support. Yeah, speed of light's a big problem. Also, the fact that it's a conceptual medium being described, that's a much bigger problem.
Yeah, conceptual being the key word.
No, I'm not satisfied because the ball earthers will say, yeah, we've got Einstein. He explains the bending of space-time. What's the problem? What is the problem now then?
Okay, show me space-time, Spurs.
Space-time?
Yeah, show it me.
You
want to show it me? And then once you've failed to show me, then explain how you're going to bend it.
Yeah, but if the Earth is a giant ball...
hold on.
It must.
Hold on. You don't need to start with there. You're so used to them phrasing everything they put to you as a begging the question fallacy in the opening sentence, aren't you, Spurs? You haven't been here a while, I can tell. No, you don't get to give me the example by starting out by telling me how Earth's spherical. That's a begging the question fallacy. Yeah, no. So back to the conceptual medium of pseudo-Riemannian force space. Apparently, space-time is being bent. So let's see space-time, and then let's see it being bent.
Right. Well, Kosho's here. I don't know if he wants to get involved or not. But because Kosho, you were talking about this earlier on, trying to discover now what is gravity. So, I mean, I'm going to go over this obviously later on with you guys. So you may as well start it off now and explain. Well, if it's Einsteinian, what next, Kosho?
No, the narrative is Einsteinian. It doesn't make it real.
Funny sounding, Kosho.
Don't be afraid, Kosho. Come on, just say what you said before about what gravity is. Is it an equation? Is it a real thing? Is it really bending space-time? What's going on?
Come on, Kosho. Share your pain.
No, I think they're getting out because only just yesterday they all conceded it's not a force. So I think they're trying to come up with a solution as to what it is. Right. So this is just a very recent collective from the Ball Earthers where they
Can I
said,
ask you a
okay, yeah,
question,
we know it's
Spurs?
not a force, but we describe it as a force. It acts like a force. We know it's not doing anything. It doesn't have any energy, so to speak.
I think Adam's got a question for you, Chemo.
Yeah, I just don't know if you want to get into it. You probably won't, because it is difficult. As we often
You know how his ear
Hold on.
goes off when he's talking.
Hold on, Owen. Go ahead, Adam. You got a question for Chemo?
I'm just trying to grasp what Spurs is trying to deal with next. So you're saying you've got them to the point where they're quite happy to say, "Yep, it's not a force." But as far as they're concerned, that doesn't matter, that definition anymore, because if we go into the world of Einstein, we can explain it mathematically so that even though it's not a force, we can put in a box why there appears to be these things that match mathematically. So they're happy with that because even though it's only conceptual, it appears to explain it mathematically. So they're therefore happy to create a force that isn't a force, even though they're happy to admit it's not a force. They're happy to generate this force in a conceptual world to just put it behind them. They're happy with that. Is that?
Well, yeah. Before Spurs answers you, though, Adam, you said that maths explains it. Well, maths doesn't explain. Maths is a language. It describes things.
No, that's the exact point, Nathan. I use it, and I know it describes. I'm saying to them, it explains them. It gives them an explanation that is satisfactory for them. This mathematical description in a conceptual medium that they've invented and placed all the rest of the physics into is a sufficient explanation for them.
I see. It works within the conceptual realm of the mathematics it's being described within. And if you accept that you're within those mathematics and that's your reality, then it works. Therefore, it works. Correct?
Yeah.
I see.
So point being then, is that what you're saying you've got to challenge Spurs next, is why are they happy to accept a conceptual medium and a bit of maths as a explanation for reality?
Yeah, yes, Adam, something like this. Like, because we've nailed them down. I think we've gone for so long by telling them it's not a force. And they've been in the idea, well, it is a force. And we've got it's not a force. So now they're like, okay, it's not a force. Einstein was right. So you're saying that they now just have, you're saying Einstein literally had a conceptual idea which superseded Newtonian, which would have been a physical force, right? If there were mass attracting mass, if that was a real thing. So we've replaced physical, what should have been, for a concept.
Yes.
No? Yes?
Yeah.
Yeah.
So you're saying mass attracting mass was a force. Yes, that would be a pulling force. The one mass, whatever that may be, attracting another mass, whatever that may be, i.e. the definition, not the object I'm describing, pulling towards each other, that's a force. Well, that wand was snapped in two by the invention of a convention in a conceptual medium by a man named Einstein.
Right.
The biggest problem.
Right.
Sorry, Adam, go on.
Well, just to finish up. So, yeah, I mean, that's it. So they were happy to get rid of that previous way of explaining it as a force, an imaginary force between distant objects. That was silly, and they were happy to get rid of that. And thank goodness they could get rid of that silliness, because now the thing that validates it is putting it into a conceptual place and putting some numbers around to prove it. Now that's real proof. It appears to be what they're saying.
Hold on. For Americans, that is sarcasm from an Englishman. I'm not even joking. That often Englishmen, the tone of an Englishman when being sarcastic isn't distinct enough for people to know you're being sarcastic.
Tongue was firmly in cheek. But that seems to be the point, Spurs. Is that right?
Yeah. Yeah, I mean that now. Yeah, I just want to bring it to the forefront. Now they concede, and they know it. Now we have to obviously ask them why they go with this concept. Yeah, is that the idea?
What's going on with them is, for the past couple of years, is they didn't understand Einstein's theories. They didn't understand his theory of general relativity. That's why they've been parroting Newtonian all the time. That's why they're always so far behind. What's after happening is, I noticed myself on YouTube in comment section, there's more of them parroting the Einstein now and coming out with some Einsteinian stuff. And it's like it's because they've started learning it. But the problem is that they're going to be parroting this stuff out all over the place, but they're going to be making mistakes left, right, and centre because they're only learning it. It's sad. They're literally only learning it, and it's their current for the 105 years. But that was the problem. They couldn't understand it. A couple of them admitted it over the time.
Big shout out to Unicorn Laser Eyes, who says, Professor Bell, come on the show if you dare. Thank you very much for the support, Unicorn Laser Eyes. Really appreciate it.
We don't concede.
Let me entice them. Let me entice them to come in, maybe, because for Einstein to work, you have to be moving through geodesics. You know what I mean? Because as you move through geodesics, you can get closer and closer, even if you're moving across parallel lines. But you've got to be moving, right? You've got to be accelerating to do that. So please explain, if you're at rest, how that's occurring, and how does time. Moving through time, so to speak, which is one of the dimensions, also causes things to move closer together. Come on, guys.
We don't concede anything, Spurs. I don't know where you get the idea that anybody's conceded anything whatsoever.
Well, I've been speaking to PhD mathematicians, astronaut sons, Rump. Now, which you can hear next around 3 o'clock straight after this, where they co-show...
M. Scott Beach? You're talking about
M. Scott Beach. They are aware that gravity is not a force, that mass is not a mass, that Einstein superseded, and it's the bending of space-time.
Yeah, you misunderstood them. In our 3D world, gravity is very definitely a force, but in...
All right. Einsteinian's 4D, though, isn't it? So...
Yeah, and it translates
Can I just ask Rumpus, is this energy you're...
Can I finish my sentence?
One second.
Could I finish my sentence? I was in mid-sentence. And the 4D space-time bending manifests itself in our 3D world as a force. Go ahead.
Right, Rumpus, is that gravity that you're describing energy?
No.
No, it's not energy. So it cannot produce any kind of force, any kind of pressure, because it's not energy, right? So you concede.
No, you don't have to have energy to have a force.
Yes, all forces have energy, Rumpus.
No.
Show me a force without energy, Rumpus.
Well, if something's not moving, there's no energy transfer. So, for instance, if you hold a positive and negative charge near one another, there is a force being exerted, but there's no energy transfer. Energy, I mean, you don't know what energy is, but it's force times distance. If there's no distance, there's no...
but all I'm asking is about the gravity that you're describing. There's no energy in that force, yeah?
Well, you don't know what energy is, do you?
Is there energy in this gravity that you describe, that you say is not a force?
Do you know that work is the same thing as energy? Are you familiar with that term? Work and energy. Do you know they're equivalent?
Probably.
Who cares?
Possibly.
Is there energy in it or not? Sorry, Chemo.
Right.
He's asked you a direct question. You've asked him a question about whether or not you understand something that's a synonym. I don't care if he understands the synonyms. He just needs a yes or no answer. Do you want to ask him again, Spurs?
Yeah. Is there energy in that gravity, that you're describing?
No.
So it's not a force. No energy, not a force. That's excellent. Thank you, Rumpus.
But it's still exerting a force, which can...
No, definitely not. That's doublespeak.
No, you don't understand. It's
No, I don't understand. No energy, no force, operating in a conceptual medium, asked if there's any energy, answered no, definitely not a force. We all understand.
No, you don't, because you don't know what energy is.
Rumpus. What? Rumpus, do you agree? Do you go along with the lines and agree that Einstein was correct?
Yes, because he described what's going on in a 4D world, and he's as he said himself, he does not contradict Newton in any way whatsoever with regard to his equations.
Well,
The breaking the wand, the breaking the wand quote. Hold on, the breaking the wand quote. The breaking the wand quote. The breaking the wand quote from Musa. The breaking the wand quote from Musa was all about the instantaneous nature of the force. He wasn't denying anything about Newton.
Rumpus. How do you explain the tides then?
How do I
on your
explain
model
the
now?
Because of the force of gravity. Force of gravity.
No, Rumpus, because you see, in Einsteinian gravity, you see, matter bends space-time, and the bending of space-time by this matter causes the effect of gravity. But that is only within the well of gravity that's created by this matter.
It causes the force of gravity.
Rumpus, can you let him finish, please?
Sorry?
I'm asking Rumpus to let you finish.
Oh. Yeah, thanks, Nathan. So, Einsteinian gravity states that the effect of gravity is caused by the bending of space-time by matter, but that creates what you call a gravity well. But the gravity effect is only happening within that well. But the moon and the Earth have two separate wells. So there is no gravity between the moon and the Earth. There was no connection whatsoever. So the moon's movements have nothing to do with the tides in Einstein's theory of general relativity.
Yes, they do. The thing about the bending. Can I explain? Can I answer? Can I answer? Right. So the moon bends space-time a little bit, and then that then causes the effective Newtonian attraction.
That's not Einstein's theory of general relativity.
Ryan, hold on.
I didn't hear that. You overtaught me. So there is, the moon does bend space-time, but the thing that breaking the wand was all about, there's no instantaneous, that the moon and the Earth do not communicate instantaneously. It's by the bending of space-time, and it's the effect of space-time that causes this force of gravity to appear in our 3D world. But the tides, but that causes things to be closer, to be attracted nearer. So obviously water that's anything, I mean, the surface of the Earth actually moves up and down as well, not just the tides, towards the moon. When it's the bit of the Earth that's pointing at the moon is attracted to the moon and is actually raised up a little bit, similarly with the water.
So this could be done with one of his field equations, could it?
Correct, yes. The field equations of general relativity
I just need a qualifying statement, Rumpus. Thank you. So my understanding was that his field equations didn't work for more than one mass. And my understanding would be that...
No, they do work.
I hadn't finished. She's scared. Scaredy cat. So my understanding would be that the Earth would be one mass. And that the moon would be another mass. And you can't solve... And he's interrupted me again.
Well, you misunderstand.
And he's interrupted me again. Einstein's field equations cannot solve for more than one mass.
Yes, you can't solve them numerically as an equation, but they...
So you can't solve this little problem that Brian's presented you with Einstein's field equations then? You cannot do it then? That would make you a liar. You're just inventing a solution that does not compute with Einstein's field equations. Now, I appreciate that while I'm saying this, you're continually talking through me so Discord can't hear. However, I'll point out that you have replied in the affirmative and now need to shut down that Brian's gotcha. That would be two masses. And Einstein's field equations cannot solve for more than one mass.
I can explain.
You've already told me. No, you can't solve this with his field equations. No, you can't equate it. Explain. You've already told us. It's just that we're at the point where you've lost, and now you need to keep this going, so the audience doesn't appreciate the demolition of your argument, which is to say that, no, this wouldn't work out with Einstein's field equations because he can't solve for more than one mass. So explain what? He can't do it.
Explain. Right, so the point is that the only problem is when you've got two large masses.
Yeah, well, like Earth and Moon. Yeah, that's two large masses, you complete moron. Yeah, that's right, that's the problem. So starting out by explaining the only problem is the question I've been posed and how I can't solve it, because we've got two large masses, the Earth and the Moon. Yeah, that is the problem. That's right. It's also the end of the argument that you're not going to assert back to us like it's a defence, you complete bonehead.
I can explain.
I don't need an explanation. You've already told we can't solve for this. While you lead the audience to believe that there might not be an ending here, there is. We know. You've conceded. He can't solve for more than one mass. And what's the problem here? Well, the only problem is that we've got two masses.
I can explain.
Yeah, you keep telling us how you can explain. You can't. He can't solve for it.
I can explain.
Stop it.
I can explain.
Rumpus, how are you helping by
I
just
can
keeping
explain.
I want to hear his
You're
explanation.
interrupting me. Why are you interrupting when I can explain?
You've already told us that's why. Are you listening to why I'm telling you why you can't explain? That's a question that you're now not listening to the answer to. Shock horror. I'm telling you that the reason I'm not allowing you to explain is because we've reached the conclusion. Can this solve for the two masses that have been described? That would be the Moon and Earth. And the answer is no. It cannot solve for more than one mass. That would be the end. Now you're saying, well, I can explain. Well, no, you've already conceded. There's no explanation required. But while I'm saying this again for the audience's benefit, he's talking through me, even though he's asked me a question. Why am I not being allowed? Well, because we've reached the conclusion. He can't do it in his maths. So there's no explanation required. If it can't be done, it can't be done.
I can explain perfectly. The point is, you can't get what's called an analytical solution, i.e. a formula, but you can solve it
Can you
numerically.
explain?
Oh, be quiet, Neil. Be quiet, Neil. Be quiet.
He's eating his mic, Neil. He's eating his mic. He's getting really angry about this because what he's normally allowed to do at this point is keep the conversation going indefinitely so the audience thinks that there isn't a conclusion that I'm making over and over again while he talks through me. The conclusion being that you cannot solve for more than one mass with Einstein's field equations. So this doesn't jive. If you've got Earth and the Moon, it doesn't work. You can't solve for it. That's the end of it. Now, he's not listening to this. He might be saying scaredy cat for all I know. I don't care. But what's happening is I'm summarising the demolition of the point, which is he can't do this with Einstein's field equations, and he's conceded. But that needs desperate obfuscation, something that the fundies on the Globe side think is a bad point. Well, no, he needs to do this. He's never going to win. He can't do it. The field equations don't work that way. Something he's conceded, but needs the audience to now brush past rather than have it reiterated over and over again by me. That's why he'll talk over and over again while I summarise it, and he'll just say, well, I can explain something he's already conceded. It's the end. He can't do it. He can't solve for more than one mass. End of argument. Rumpus has lost. Someone in...
Yeah,
go on, Brian.
The very claim by Einstein that gravity is an effect caused by the curvature of space-time by matter completely disproves everything Rumpus is saying. He's literally going against Einstein.
Yeah, he's completely shut down communications in Discord now. I'll just let the audience know that. That's why his light's permanently on. He's not listening to anything anybody says now, hoping that he can obfuscate the point for maybe a few people in Discord. Okay, fair enough, Rumpus. Keep talking indefinitely. I'll just point out once more while he talks indefinitely that Einstein can't solve for more than one mass with his field equations. Just point that out. Thank you.
Well, I'm kind of curious that if Rumpus really thinks that he can do that, I'd like to hear what that entails to really make sure how delusional he is about that assumption, if that's okay with anyone else.
He won't listen to a question to you. He's completely shut down all communications with Discord.
Right, but we've basically concluded that the field equations of Einstein cannot be used, but Rumpus seems to be wanting to say that he can. So I'm kind of curious as to, in his mind, how he thinks he can do that. Already knowing he's going to be wrong, pretty much. But I'm kind of curious.
You can solve it numerically. You can solve it numerically.
Numerically? Well, we don't live in maths. We live in the world of physics. Physics deals with the real world, not mathematics.
Maths is the language of physics.
Sorry? We don't live in a mathematical abstraction. Maths is abstract, you complete bonehead. You can solve it with maths. All right, solve it with physics. Physics deals with the physical. Mathematics deals with the abstract.
No, it doesn't.
Yeah, it does. It's a description. It's a language.
Yes.
That's what you got, Owen. That's what he's going to do. He's going to say he can solve it with maths. That's what he's going to do. There you go. You got your answer. You happy?
Right, so math is reality is basically his foundation.
No, mate, not math is reality. He's obfuscated the point. He's saying he can solve it with maths. No, the maths is his field equations, and he can't solve for more than one mass in his field equations. That is the maths that he's conceded doesn't work, and his rebuttal is, I can solve it with maths. Now, the physics of the maths it's describing would be having more than one mass. And when I say do it in physics, that would be the physicality. It can't even describe it with the maths. That's my point. It's where he loses. But his answer to that is, I'll go back into the abstract and explain it away. And ignore the fact that it can't solve in the maths more than one maths. That's what he can't get around, Darwin.
Yeah, little dodge, right? He can solve it numerically. Well, aren't the equations numerical? I'll tell you what.
Maths is
let's give him a chance. Let's give him a chance. Show the field equations. Watch this. I want you. The only way that you can recover from this.
We've got an idiot installed.
Oh, he's going to poison the well before you ask him a question.
The only way he can do it. Go ahead. Let him show the equations. We want you to solve it for the moon causing the tides with Einstein's field equations. That's the only way. No explanation. Do it now.
What you do
I'll
is
go
you
to
reduce
Discord.
it to
Put it in Discord.
Listen, stop being interrupted already. Be quiet. Right. So in this situation with the moon and the Earth, fortunately, you can reduce that to Newtonian equations and then solve it like that. Very easy.
Oh, that's from Einstein.
Sorry, reduce it to Newtonian. So we're asking you to solve it with Einsteinian, and you're saying you're going to change it to something else immediately. No, we want you to do it within the Einsteinian. Did you not understand what we said? Do you not understand English?
Reduce it to the Newtonian.
So you're saying reduce it to something else over and over again. You can't solve it with Einsteinian then, because it's been superseded. We're not using Newtonian anymore. Einsteinian replaced it. It snapped that wand in two. Not forces of mass attracting mass, not Newtonian. Einsteinian bending of conceptual mediums, travelling through geodesics in space-time. No, not Newtonian. The reason you need to translate it into something else is because it cannot be done. So was this what you were desperately trying to interrupt me and talk over me for the last straight 15 minutes? Because you were going to change it into something else? Oh, right. No, the reason, ladies and gentlemen of the audience, he needs to change it into 105-year out-of-date rhetoric is because Einsteinian field equations cannot solve for more than one mass.
And as Einstein said, Newtonians, he did not replace anything of Newtonian's equations at all.
I'm still waiting for the equation.
Yeah, we're still waiting.
Still waiting.
In simple situations, so you can use Newtonian
We're still
equations.
waiting.
So we're not asking you to use Newtonian. You could, like you could think of gravity as a force. You could do that. We're asking you to use Newtonian, though. Einsteinian, though.
Yeah, and it reduces to the Newtonian.
So you're just going to keep telling us how you're going to change it into something else and then not do anything? Because we're asking you to solve for this little problem Brian put to you about 25 minutes ago with, Einsteinian mathematics. Surely that would be possible. Oh no, my point that you can't solve for more than one mass still hasn't been rebutted in any way, shape or form, other than saying that you're going to use something 105 years out of date.
The math says you can do that.
The maths in Einsteinian says you can't solve for more than one mass.
But you can, in simple situations, you can.
Let's do it.
Go on then.
I'm
But
still
not
waiting.
in the general case.
Go on then.
And
I'm still waiting.
And in the simple case,
I'm
when
in
you've got something
Discord.
like the Earth
Shut
and
the
moon,
fuck up and
you
put
can
the damn
get
equation
hold
down
on,
here
don't
and
interrupt me.
solve
Let
it
someone finish.
for the damn tides with the moon and the Earth.
Yeah, solve it for the tides. That's what you were asked about 20 minutes ago. Just for the audience's benefit, he hasn't done it.
He doesn't even
because
know
you-
the equations.
If
How many equations
were
does
here,
Einstein?
he would say, in the simple situation, the Earth
We
and
don't
moon,
want to
they
hear
reduce
anything.
Newtonian
Solve
equations.
the equation. Do it now.
Yeah, it's all about the maths. You said you could solve it with maths. We want to see the field equation from Einstein solving this problem of the tides. Go.
You can't make the math.
Do you want me to actually show you the procedure to reduce the general relativity equations to the
Admit it.
Newtonian equations?
No. Did ask yourself this, ladies and gentlemen of the audience. Did we just ask Rumpus to show us how Einsteinian reduces to Newtonian, or did we ask him to solve the problem of tides, that would be two masses, with Einsteinian mathematics?
But they convert to
Rumpus, you
Newtonian at
appear
that
to be
level.
So he's telling us how they convert to Newtonian, ladies and gentlemen. doesn't seem to be solving this maths that he told us was solvable with maths. And obviously, as we're talking about Einsteinian maths, we want it solved with Einsteinian. Now, as I'm going to tell the audience fact, he cannot do this. It's not possible. Einstein's equations will not work for more than one mass. He'll tell me when we ask him to show us it doing it, which it can't, that he can reduce it to Newtonian and ask me if I'm asking him to show us Einsteinian reduced to Newtonian, which we're definitely not asking him for. So this is merely an obfuscation of the fact that Einsteinian, now we're all on that right track of the right pseudoscience. Heliocentrism needs to be parroting Einsteinian. And here we are within a day of Spurs giving us this good news, us absolutely pummeling the Einsteinian that they need to adhere to. But it doesn't take them long to revert back to the old 105-year out-of-date rhetoric now, does it? As Rumpus is demonstrating. And why is he demonstrating that? Well, because he can't solve for more than one mass.
It is perfectly.
Perfectly, he can't solve for more than one mass. That seems like a piece of crap to me.
Math. You look at the equation for Einstein field equations.
And they can't solve for more than one mass.
Let's go, do it.
Go on then, let's see it happen.
Okay, so you want me to? Okay, I'll show you the maths. I'll show you the paper that demonstrates this. If you
Not
like,
the
you have to
paper.
let
I
me
want you to
share.
do the math right now.
Okay, right, I'll go and get the paper. Hold on.
How many field equations does Einstein have?
I think 10 partial differential equations.
Okay. Yep, that's correct.
Totally.
Go ahead and put down the equation and solve for tides between the moon and the Earth.
Right, first of all, I'm going to reduce them to Newtonian equations.
Sorry, we haven't asked for Newtonian.
There isn't any Newtonian in it.
But there is. They reduced to Newtonian equations.
Sorry, ladies
Where's
and
the
gentlemen.
Newtonian mathematics in Einstein's field equations?
Let's just point it out again for the audience. He's been asked to solve for the tide problem with Einsteinian. Why am I being talked
You
through?
probably could if you lift it up and put your legs under and then drop them.
Anthony, go on mute. I'm crying out loud.
Pardon?
He's been asked
Go
to
on mute. We can hear you.
been asked to solve the tides with Einsteinian. And he said, yes, I'll go away and get the paper. I'll show you how it reduces to Newtonian. Again!
Yeah, because they all reduce.
We're not asking you to reduce it to 105-year out-of-date rhetoric that's been replaced, superseded by Einsteinian. We want you to use the Einsteinian.
But they all reduce to Newtonian.
We don't care what it reduces to for about the 10th time. Now, I'm going to tell you why he keeps pointing out, like I said earlier when Alwyn was like, no, we need to know what he's actually going to try and get around with this. He can't get around this. He cannot. Einstein's field equations cannot solve for more than one mass. So he can't get around it. All he can do, and that's the only tactic, it's necessary. Because to the audience perception, like Arwen's perception, oh, maybe he's got something really juicy. No, he hasn't. What he's got, it's endless assertions that are going to reduce it down to 105-year out-of-date rhetoric that's been replaced with the very Einsteinian maths he's been asked to use and can't. So dilute that by saying, I've got an answer, maths solves it. Okay, show us the maths. Well, I'm going to show you the paper that reduces it to 105-year out-of-date rhetoric. We don't want that. We want to show you solve for something that cannot be solved by the very admission of Einstein himself. Well, no, I'll reduce it to something else. I'll get you the paper. Round and round we go. Now, understand, audience members, that you're heliocentrists with a dying globe religion. And we're here to highlight just how dead it is. Now, Rumpus, who you all maybe or maybe not feel is somehow not a good debater because he double speaks and obfuscates, know this. Without this little session of double speak and obfuscation, you'd have absolutely nothing. Because all he'd be able to do is concede he can't do it. Now, he can't do that, can he? Can't show up Einstein's failures. But what he can do is claim he can solve it for maths and then not do it. So you think he might have something up his sleeve? He hasn't. You've got nothing. Nothing. With that, I'll say if you're watching this on either a Nathan Oakley 1980 or Nathan Oakley premiering stream, then stay tuned as there will be an after show to follow. Unfortunately, if you're watching this live on Nathan Oakley 1980, this is where we bid you farewell. A huge, massive, enormous thank you to all of you who smashed the super chat, liked, commented, shared, subscribed, and all that good stuff. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. Once again, stay tuned if you're watching on a premiering stream. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!